I can introduce, right? Okay. So we have Pete Bernard, who, after 2 decades at Microsoft and extensive work in Silicon Valley, Pete now leads at Chelsea, I'm sorry for pronunciation, and serves as an executive director of the Edge AI Foundation. He is driving force behind product innovation at the edge across AI, 5G, and semiconductors. The Vijay Janapal Reddy, a professor at Harvard University. Vijay brings a research to lens to Edge AI with a focus on computer architecture, energy efficient computing, and real time AI systems in everything from autonomous vehicles to aerial robotics. Evgeny Gusev, a senior director at Qualcomm AI Research and chairman of the TinyML Foundation. Evgeny is the forefront of ultra low power machine learning. His work shapes the silicon and sensor designs that enable intelligence on even the smallest edge devices. And our alumna, Didem Unantes. Didem is the founder of Lotus AI and leading voice in responsible AI, advising global firms like Goldman Sachs on AI strategy and talent transformation. She has held executive roles at Schneider Electric and Microsoft, where she led groundbreaking GenAI and responsible AI initiatives. A World Economic Forum Fellow and AGI Foundation board member, Didem brings a rare blend of enterprise innovation ethics to the AI conversation. So those are our guests. We can now dive in. I have my own interest and questions that I'll be asking to our guests, but feel free to interrupt me and insert your questions as well. This is for the audience. So the first thing that I am interested in, and I want to clarify for us all, what are the unique constraints and capabilities of Edge AI solutions compared to purely cloud-based AI solutions? And I think Evgeny would be the person.
Yeah,
Yeah.
Thank you, George, and I can take this one. And thank you, George, and also thank you, Didem, our member of the board, for organizing this event. Really excited to be here. Yes, when we talk about Edge AI and TinyML and compare it to the more conventional cloud AI, there are some very unique attributes, like fundamental attributes. First of all the AGI devices, they're limited in terms of how much compute is available to run different workloads. Typically, those devices have only like megabytes of memory and only like few tops of compute. And that's a challenge. But on the positive side, this challenge always opens up opportunities to be able to develop solutions in the edge AI space. Companies and developers, they really need to innovate and think out of the box. How do you connect all these algorithms and software and run this on these devices? And that allows people really to develop very, very energy efficient solutions, which is important for AI scalability. And what we also see, once these solutions are developed for edge AI, then the cloud people also adopt the solutions, like, for example, reduced precision. Instead of running AI in the FP16 or FP32, you can do it at the reduced precision. And that's a common technique used in the cloud, but it was originated from the edge AI. So that's one fundamental difference. It's really the edge AI devices are constrained in terms of hardware resources available there. Second fundamental difference is, and that's also important, it's related to data ownership or data source. We know that now AI, the big AI, the cloud AI, is limited by the data available. So after mining all the internet, which is only 4% of the available data, all the models are pretty much plateauing because of there is no more data available. It just again the amount of the internet. And what Edge AI opens up, it's really a unique opportunity to dig more data, because Edge AI is ultimately and intimately connected to the physical world. In fact, the tagline of the Edge AI Foundation is connecting AI to the real world. And that's where the source of the data is. I think according to Gartner and other research, 95% of the data is based in the physical world, obviously. And that's what Edge AI fundamentally allows to do, is really to collect this data from the physical world and make it meaningful, make it actionable. Those are the two things I think to keep in mind when we talk about Edge AI compared to the cloud AI. Again, the resource constraint and the data ownership and all the related business opportunities to this too.
Wonderful. And so basically, as AGI serves as a data source and as a tool that uses those algorithms, right? There are two distinct roles that are important.
Correct.
Okay. And about use cases, can you guys share use cases where Edge AI outperforms centralized approaches in terms of latency, reliability, or privacy? Maybe Vijay.
Yeah, I'll actually intentionally pick something that most people from industry wouldn't think about, which I think is like the interesting value of this is Edge AI, I think has got very interesting value proposition for education, for instance. I'll intentionally pick that because it's a different perspective. And I think it's primarily because, traditionally, if you kind of think about much of, whether you're trying to build these systems or you're trying to train the next generation of engineers and try and, build them up, it's very hard to do it when you often just kind of talk about these abstract, how many of us is going to actually program ChatGPT, right? Or Gemini, right? Or Anthropic's Claude. Like, it doesn't simply happen. I think one of the unique value adds, I think, with Edge AI is just it actually enables us to truly be able to train the next generation of AI engineers because the models are not that big. The data that you're dealing with is not necessarily of that same magnitude and scale. You don't need to scour the entire internet. And I think in education, I definitely see that as a unique, super unique value add. And there's a lot of innovation that I'm actually seeing around ed tech around this space. But in terms of industry wise, I mean, there's certainly lots of benefits. And I'll actually leave that up to Pete and Pete and Evgeny, you can chime in because they can chip in from the industry perspective. I just want to give a very different point of view.
Yeah, no, I think that's good. That's a good point. Is like, Edge AI as opposed to cloud AI is much more, I think, easier to syndicate and democratize to people to learn and to implement, frankly, locally. But I mean, one of the canonical use cases around why you want to run AI workloads is really like running AI software in the cloud or running AI software in the thing in the real world. Those are the differences between Edge AI and cloud AI. And AI vision is a classic example right now. It's being used a lot, especially like we just had a live stream about pedestrian safety. So, using cameras to detect when pedestrians are accidentally crossing into roadways and other things like that. When you're doing AI vision in kind of safety and security scenarios, you don't want to be sending video feeds back to a data center miles away to see if someone's going to cross into the roadway. You have to just act on that data in real time. And so the ability to sort of analyze video streams and act in real time or near real time is a classic use case of Edge AI versus, sending stuff back to the cloud. The other issue is as you send stuff back into the cloud, it costs money. There's money on communication, connectivity. There's money on the ingress and the egress of the data. You're paying a cloud vendor, for services. And if you're doing that processing in the camera itself or in the gateway that's deployed in the industrial environment, then there's no extra operational costs to processing that data. So we're seeing it, in smart cities. We're seeing it in water systems, agriculture, aquaculture, healthcare. Walk into a hospital, and pretty much every machine you see around you is probably running Edge AI in some form or another locally. So it's really becoming a pervasive thing. I say that there's a gravitational pull toward the edge for compute in general because it tends to be lower cost, lower power, more control, more privacy, and more impact.
And just to add to the last point, I think at Qualcomm, we talked to a lot of customers on Edge AI. And one area that really clicks is like what Pete mentioned last bullet is the privacy, because for many applications, privacy is a must-have feature. And people are really concerned about privacy with cloud-based AI. But that's what Edge AI intrinsically and by design offers to these deployments. It's privacy, data sovereignty, and security aspects there. It's built by design into those applications.
And I'm judging by the standards that apply to cloud. Are they equally safe? Can we say that today, or even better safe from privacy perspective than what cloud can provide us with?
It's much, 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 much better safe in a way because when you talk to the cloud, you have all the software related hook and software can be hacked. But when you talk about edge AI, some of the safety is actually baked into the hardware, so it cannot be hacked, period. Like I think VJ and with some companies, they lead this initiative on smart sensors. Basically, those sensors, they don't, the data doesn't leave the sensor. They stay at the sensor level. Or people only see the metadata, like how many people are in the room, what is happening in the train station, those kind of things. So, especially in Europe, privacy is a big deal. And there is always skepticism about like how safe is the software enablement of privacy. But again, when you talk to edge AI, and again, it's fundamental. It's all enabled at the hardware level. You cannot hack it, period.
Right. Yeah, there's this, they say data in motion and data at rest. And anytime you move data outside of the device to another device or to the cloud, data in motion is inherently riskier than data at rest. But
yeah.
And what about the future from strategic perspective in organizations? What cultural shifts are necessary for large enterprises to successfully adopt edge at a scale? Them probably.
Thanks, George. But before I answer that, I do want to say, first of all, Evgeny, Pete, and Vijay have such a wealth of information on Edge AI. My huge wholehearted thanks for them for accepting our invitation. I would also suggest that for my War Tonight friends here, if you're interested in this space, please do become a member of Edge AI Foundation. It's a nonprofit. There's a wealth of resources, incredible people from everywhere, government, academia, startups. So I take it on me to market Edge AI Foundation, but it's for good cause. So to answer your question about the organizational talent transformation needs, I have been in the space, AI space, for 13 years, and I can't even count the number of organizations I've had the pleasure to help on AI transformations. So in general, AI transformation is about leadership vision and courage and commitment, because it's not an easy journey, right? We will fail, we have to invest a lot, etc. Second is culture. Then, I used to say data first, but literally in that leadership, culture, and then data, whatnot, In Edge AI, and of course there's talent piece, huge, factor of success in AI in general. For Edge AI, I think all of these are even more important, even more essential, because, for instance, at Schneider Electric, I used to have a team of embedded AI, which is a kind of a, let's say, subcategory of Edge AI, embedded AI, TinyML, and that's why I'm actually on the board of Edge AI Foundation. And this talent is so hard to find because they have to know both microelectronics, the hardware, the software, and be also on top of their game in AI, cutting edge, and we just keep it literally changing by the minute. So I would say talent. And lastly, and that's why I kind of marketed Edge AI Foundation in the beginning, it's about ecosystem. It's about partnerships and alliances, because it's much more complicated than this closed elitist, kind of exclusive world of typical AI. You have to bring everybody together to play the game together. Evgeny, Vijay, please jump in if I missed anything there, but I would say critical for success, those would be the ingredients.
Yeah, just to add a data point here, that's an excellent point, Didem, but I think the one data point is about 2 years ago, Vijay and his team at Harvard started a TinyML EDX class that has become virally successful. And just to give you a data point, over 2 years, over 100,000 people worldwide, I believe, Vijay can correct me, in 170 countries took this class. And that's a testimony in 2 ways. One, it shows the democratization part of Edge AI, how powerful it is to democratize AI. And second, think about this. This 100,000 people get trained into this. There is a massive workforce is prepared as we speak. And as market is going to be developed for AGI, it creates a lot of interesting business opportunities. You have technologies, you have market, you have workforce, and you can start putting all the things together and really generate value in all these different things, verticals, applications, and technologies. It's really powerful value proposition moving forward, in my perspective. But again, the talent is a big part of this, and thank you to Vijay and educators all over the world who are dedicated and committed to developing this workforce and talent in AGI.
About that, Vijay, how do you think how should traditional software engineers and AI specialist engineers adapt or reskill to handle these unique hardware and latency constraints that AGI provides?
Actually, I think it's more than just specifically about edge AI and the latency constraints, George. I think like, right now, just taking a step back and kind of thinking about this AI ecosystem that Evgeny's kind of mentioning. I often like to say that everybody wants to be an astronaut. Nobody wants to be the rocket scientist nowadays. Let me explain what I mean by this. Is that right now there's so much movement in the AI space from an algorithmic sort of a standpoint. And I'd almost argue that in the future, if you look at it from a job definition standpoint, I think like a lot of those jobs are kind of a lot of the traditional computer science, that side of the jobs are actually going to disappear because in a way AI will eat itself to an extent. I'm not saying the human in the loop is not critical, but I think the number of people needed is going to shrink quite dramatically. But the place where we do need that talent generation is on the core side, on the rocket side. My point being that you actually need people who understand how to build the systems, because much of the AI we see today is not pure algorithmic innovation.
Yeah.
If you look at ChatGPT stuff, it's almost 8 years old. Believe it or not, we get excited about it, but it's really old technology from my standpoint. But even academically, you talk to Jan Lucan, and all of them will say that's like brick and mortar style technology. But why is it so exciting? Well, it's not because of the algorithms. It's actually the system infrastructure and engineering behind the scenes, and that's what's really driving much of the innovation that we see today. And that is also going to be the thing that's actually going to be driving much of the innovation in the future. So from an engineering sort of a workforce and training sort of standpoint, I think it's going to be really important to be able to tap into that space and kind of build that, workforce talent. I think that's a really interesting opportunity. And when it comes down to that latency question that you're asking, so forth, and George, like you have to understand the nuts and bolts of what that system aspect is, because it's not really the algorithmic aspect that's going to fundamentally change or affect that deployment. What's really going to affect the deployment is really how you engineer the system. And I think that's where the golden opportunity really is. And I think that's inherent in the edge AI sort of a paradigm that we're getting into.
Right.
I don't know, Pete, if you want
Which
to jump in.
technology you said was old? Just to clarify that again.
Yeah, I would say that it's actually quite old technology. Right?
What specifically what?
The underlying technology that's behind ChatGPT or Claude. Or
Okay, thanks.
The fundamental building block is about 8 years old, really old.
That's old, yeah. Well, I mean, the term artificial intelligence, I think, goes back to like 1957 or something. So
yes, actually, the first papers I found about was like in Ukraine, and I think it was in Ukraine the way like AlexNet like structure was described, something like in 67. I'm not sure.
I think to Vijay's point on development, one of the areas where we have the AGI Foundation is a community of partners that work together. And I recognize it as sort of the whole stack from metal to cloud. We have chip people, firmware people, model people, app people, device people, but we have a lot more kind of solution providers. I call them solution providers. And these are technology companies that know how to think systemically about AI and edge AI solutions and how to design and deploy them. And I think that's a really fascinating area. I mean, to Vijay's point, it's like understanding how to apply edge AI and TinyML to solve real world problems is a great opportunity for folks to learn about.
Sure.
I think Eric had his hand up there. I saw.
Yep.
Can I, because I'll tell you, like, Vijay, I really like what you said. And George, when you and I were talking this weekend about the website stuff, and we were talking about like prompting,
Sure.
What do you do when you prompt? It's who do you want to be? I love the life or death aspect you added to it, but then it's context and then it's the output. So I agree with you. Like, you asked what was there. 20 years ago at Thomson Reuters, 0.72, we're using all this to do analysis on news feeds and do trading. Not a lot of it's not, but what I'll tell you what's changed, it's the LLM aspect to allow the end user to finally start to input context directly. And it's something I keep trying to figure out. There was a LinkedIn post that Benny had, and I keep trying to find it on our WhatsApp. And it was so brilliant because this person came in and they said, this is going to miss the exact same way that RPA, that everything else is missed, because when work is done, there's usually a hero. There's usually the context of what it's done isn't captured correctly. So when you don't get all of that in there correctly, it might get us another step down the road, but it doesn't get to that robots go take everything off our plates and we just hang out at the pool with margaritas all day long, because the context is missing. And I still can't find it, but it really popped on me, George, when we were talking about, like, that's what's changed for me, that now an end user can sit down with ChatGPT, write in their context, and get something directly back without the engineers, without people like us in there to do it. And I think the deployments and the real value is going to come when, in that sense, where your context is closer to the person actually doing it as it gets implemented. I don't know.
And then walking into the neighborhood, hearing what I do wrong and how I speak. And in class, to any the next time you say anything to me about my goals and decisions for the world.
Someone asking a question.
Yes, it was not clear. I couldn't hear. Can you please repeat the question? If this was a question. Yes.
I wanted to speak a little bit to Vijay mentioned
Sure.
in the chat about physical AI. I actually spoke last week at an event in the Bay Area on physical AI. And in fact, if you go to our website, I published a paper on physical AI last week as well. So good, Vijay, that was a good setup. But it's interesting because, physical AI, and I think maybe to Eric's point too, like now people are personally interacting with AI like they haven't before, even though the technology has been around. So they're personalizing it. They're sort of finding the right context. There's also, unfortunately, because this is where we are in society, is there's a lot of overhype on AI as well. A lot of overhype on what it can do. And it's going to be, a robot's going to follow you around the house and wipe up your coffee spills and all this other baloney. And of course investors are involved. Some of us are investors here. And so there's this kind of hype cycle that cooks, with AI. And at the engineering level, like we kind of understand like what this stuff can do and what it can't do and where it's heading. And we're trying to build it so that people can use it. But we also have to be responsible about, what's possible and what isn't right now and where things are heading. And so at this physical AI event I was at last week, I gave a talk and then I was on a panel. One of the folks that was on the panel had one of these, they had built a humanoid robot, and they had it there. It cost like $16,000 and it was like 4 feet tall and it danced around and stuff. And, I kind of was very polite, but I was sort of like, this is not solving a problem. So like we talk about robots solving problems, there's lots of really important problems that they can solve, even if they're not humanoids. And so there's a kind of this interesting thing as regular humans, interact with AI and come up with all this great context. It's pretty awesome. But it can also generate a lot of kind of nonsense hype that maybe it kind of masks the real value of what's happening out there with AI in industry. So,
yeah. Peter, I have a question actually regarding the GPUs from investment perspective, investors' perspective. There are many linear algebra solutions that make it much easier at inference time, at least, to do inference without those expensive GPUs. I think the startup was doing was MIT startup Neural Magic, which was bought by Red Hat, I think. They tried something. I'm not sure what exactly they were doing, but I know that it was pure math. It was not like discovery of hardware or something, at least from what I remember. So how relevant is this for small devices and especially edge AI? And also, how do you think why this is not showing up in on the market, those solutions, or they are showing up in the solutions that Amazon and Microsoft are manufacturing in terms of removing some redundancies from NVIDIA GPUs? What do you think about that?
Yeah, and I'll let Evgeny chime in on this a little bit too, since he can put his Qualcomm hat on. But there's training and there's inferencing, right? And so there's lots of new things happening in creating more efficiency on both sides, right? People want to train more efficiently because they don't want to spend that much in the cloud, and they don't want to build billion-dollar data centers that have to have their own nuclear power plant attached to them, which kind of makes no sense. So that's the training side, and NVIDIA, if anyone hasn't watched some of the GTC live streams from a couple of weeks ago, I encourage you to do that. They're doing a great job, fantastic. On the inferencing side, you don't need a high performance GPU to do inferencing in most cases, right? You can do inferencing much lower power, sometimes battery powered even. And so there's lots of different ways to do that. And people are building, what we call NPUs or other types of compute infrastructure to be able to do inferencing at much more efficiently than you would on the data center training side. So I think we're going to continue to see, innovation there, and amazing innovation. As to why it doesn't get the kind of the Jim Cramer hype as NVIDIA does, well, I mean, you can look at the dollars and the money, and people tend to be excited more about that stuff. And also the edge tends to be more heterogeneous, right? It just tends to be lots of different players out there with different devices and different things. And so it's not just sort of a winner take all market. And so it's a little harder maybe from an investment perspective to sort of to go for that. But that's just my perspective.
Yeah,
Evgeny,
sure.
I don't know if you have any.
Yeah, no, I think I can. I think George, you had a comment, or you were
No,
going
no,
to
no.
ask?
Yes, I was gonna ask you.
Yeah. No, I think 2 points to make because you brought up two questions. One is what are the technologies for the edge, like newcomer technologies, and the other one is do we see these technologies in products? So to the first point, just again, fundamentally, energy efficiency is one of the key value proposition for AGI. And just to give you a data point, which was astonishing to me, what I heard is that to run a stable diffusion model, just to generate an image on the cloud, it consumes equivalent energy of your phone battery. So basically, you generate one image just for fun or whatever is needed, and your phone battery is gone. So
Yeah.
think about this. Like I think it's insane to use it that much, and that's what Edge AI allows to do. So it's really to do it in a very, very energy efficient manner. Today, it's still inefficient. People use digital accelerators, matrix multiplication. You said linear algebra, but some researchers are looking at fundamental ways to improve it. And there are several technologies and several startups. And actually, those startups are quite successful. I just saw this morning one startup raised 40 million just to do this. It's a compute in memory, one of the techniques. So instead of doing compute in your CPU or NPU, and you move data between memory and compute back and forth, which is extremely inefficient. That's where you burn most of the energy. You just compute in memory cells itself. So there is this technique. There is analog compute. Instead of doing it in the digital domain, you do it in analog domain. There are some startups in this space. There are some interesting startups in neuromorphic. That's probably what you referred to, this neuro company.
Yeah, it was Neural Magic, but they should be similar. Yeah.
Yeah, so I think neuromorphic computing, instead of doing like in a digital way, it's an event-driven spike computing. That's how our brain works. You don't compute all the time. You just compute when you see something, right? You have a spike and your neurons fire, and you get the compute done in your brain. So there are some techniques there. So there are several startups and academic activities in this space, and typically they offer more than 10x improvement in terms of efficiency, which is, as you know, from the business world, 10x is good enough to justify investment into these areas. So yeah, quite a bit going on there. I think we're going to see more happening. These technologies are becoming more mature. The software stack is becoming more mature there. And on the product side, definitely see more stuff happening on the cloud monetization, but we also see more activities at the edge. Pretty much every member company of AGI Foundation, they have products of different kind. You see some of these products in big companies, like you mentioned, Amazon. These devices, they have AGI TinyML technologies built in those. They're just not promoted to the level you see about ChatGPT type of things, but it's happening. Like serious companies like Schneider and other companies, they use this in products. So it's happening as we speak, and that's why I think we are bullish about Edge AI in general, because the market is getting ready. There are more use cases, there are more technologies, there is more investment into the space, there is more talent, like what we discussed before. I think it's going to be really more. And I think someone asked it also on the chat, like, hey, what about NVIDIA? Yes, NVIDIA is also thinking about this, and I think the last GTC last week, they started to talk about Edge AI and physical AI. Because again, AI is moving from training to inferencing, and inferencing is like where the data is at the edge. I think we're going to
It
hear
was
more
in
and
the,
more. Yeah.
sorry, Evgeny, I didn't mean to interrupt, but it was
No, no.
definitely in the keynote. And one of the things that, I mean, for those of us who may have watched it or been there, for me, it was quite something to hear about T-Mobile, Cisco, and NVIDIA announcement. I think that's a big deal.
Yeah. Yep.
Going in terms of democratizing AGI.
Yep.
Yes, and Eric has the same question. Actually, I was gonna say, is there a 10x improvement or not? But yes, we already said that there is. So, Eric says, you mentioned 10x return as sufficient. What type of hurdle rate are you seeing at the floor for making the investments? To someone else's earlier point, there's a lot of hype. So curious what a realistic expectation for investment is. If I think this is the
Does that make sense? Can I?
Yeah,
So there's
please.
usually a hurdle rate. Like when you do strategy, you'd say you need at least, I can get 15% of my money if I do something else with it. I need 25 per, 20%. Most companies have that rate. For AI, you say 10x. Oh my God, of course they're going to do it. But, to me, I think becoming more realistic. So what do we really think that I always call it a hurdle rate is for someone to make the investment? What do they really need to see in a return on
it? George, shall I
Yeah, sure.
tackle that? So Eric, fantastic question, and I don't have the magic answer, but I was at a very impressive conference, AI conference, about 2 weeks ago in Las Vegas. 3,000 AI experts and AI investors. Very niche conference. And the whole topic was about how do you invest in AI? How do you make sure you invest well in AI? And what kind of returns should we expect? So I think some of the key themes to watch out for, and I don't think there's a right or wrong answer to your question. It's a great question. Please don't get me wrong. But the things that came out very consistently was founders. Like the fact that investors are taking more risk in a real-time changing, super dynamic, for many reasons, geopolitical reasons, technology reasons, startup reasons, etc., means that people who've been there, done that, and have executed well, just like any VCPE decision, right, is even more important today than because you can rely on them. The other theme that was repeatedly in many sessions was ARR versus ERR. Experimental run rate revenue versus, because many of these companies are showing some very fantastic, impressive stuff, but it's not actually real ARR type revenue that we can rely on. So for me, with my half technical, half business, let's say, background, I would say R&D, where are we investing our very precious money on? Of course, hopefully talent and the right bets in terms of technology. But from a return perspective, it is about doing, track record, and proven success for the technology, not just some very exciting feature or whatever. Happy to talk offline more. I have my notes.
That's good. Can I add a point though? Because
Sure.
the investors. What I was looking more like hurdle rate from a company perspective. So somebody said NVIDIA. when I worked at WWT, we did all the compute NVIDIA for the last 10 years. That's where you go. If you want GPUs, you go there. And companies had a rate before they would invest the money to upgrade the compute they had. They needed to see an internal rate of return on it. And I'm just curious where that level is right now to warrant, like J&J, I hope there's nobody here from there. When I was there and we did all theirs, they did the parallel that they now had 14 lanes on the highway of compute, but they only needed 2. And so I'm wondering where that level is at for them to want to make more investment to do the stuff, to do the edge, to do some of the stuff like that.
Eric, again, very happy to take this offline, but I help, for example, Goldman Sachs with their due diligence, AI due diligence efforts. So it is a lot more dimensions and a lot more parameters to think about. Like literally, I built AI playbooks, AI cheat sheets, like how to do due diligence for AI and responsible AI. By the way, it's part of the return side of the equation. I do want to mention the importance of responsible AI. Like as Evgeny and Pete mentioned, yes, edge AI is a lot safer because it's on, but at the same time, if something goes wrong, it's much bigger mess to deal with because so again, not the topic of today. We have another webinar on responsible AI, but I do think that this technology will go wrong. It's part of the nature of the beast. And if we don't put the guardrails, it's just a matter of time. Just like cybersecurity, if we are not buttoned up, it will explode. So anyways, but that's a different webinar in May, I think.
Actually, if I can double click on the point, I'm really excited that she brought this up because I think this is one of those Achilles heels of these systems. Is it okay if I share a plot?
Yeah, sure.
Just for a second. I think it'll be much more engaging.
Are you able to do so? Because I'm kind of, yeah, you should be now.
Okay, great. So I'm going to just share something hypothetical, something that I'm working on right now to Dietem's point, in fact. So one of the things is obviously everybody's very excited about, oh, everything is going to be in the edge. It's going to be great for privacy reasons and all that stuff. And as Dietem kind of mentioned, there's a rather critical junction you have. So let me explain it from the point of the plot. So I'm very interested in this trade-off between safety and efficiency, right? So Dietem's kind of worried about this responsible AI side, which we can kind of lump into hallucinations, models making up stuff, models being biased. There's a whole taxonomy of that, right? So let's just assume it's on the y-axis as safety risks, right? And the x-axis is essentially the scale of the model. It starts with a very large model, so it's inverse. So you could think of it as we're talking about things to the right-hand side, right? And the whole concern here, in my head at least, is like, as you basically try to make these models more efficient, in other words, you have to pack it onto your phone and you have to pack it into the small Alexa device that's on your kitchen. What you effectively end up trading off is that safety curve. Because at the end of the day, these things are not orthogonal. People think of these as like 2 separate things that you can, I'll build it and then I'll kind of fix it later. It doesn't quite work because at the end of the day, when you kind of go back into it, it's the same set of bits, the numerics that you're manipulating. And all you do for efficiency is really cut those bits down in some capacity or how you compress them down. And when you do this, what ends up happening is the bigger models that are kind of running in the cloud and so forth, and traditionally be much more robust and safe, and you can have good responsible AI principles around it to safeguard the models. And then as you go to the right, as you try and scale things down, your safety risks can start escalating. Now, this is a hypothetical curve, but one of the things that we're doing is trying to back this. We have sample data points, but obviously you had to flush it out very carefully. But I'm very glad that she brought this up because I think it's one of the biggest things that people are not talking about, or perhaps this is academic in nature, where you want to really understand this. If you don't do this, it's gonna blow up in your face so bad that's
VJ,
one blow up.
Thank you. It's not academic at all. I worked on a daily basis with Office of Responsible AI at Microsoft for years. It's very real, very commercial, it's massive. And it has to start from day 0.
I fully agree with you. It's massive, but what I'm saying is that when it's massive in the conventional sense of you can point to the big elephant in the room and say, ChatGPT got something wrong. And the concern that you are forecasting, which I agree with, is you kind of scale these things down, it's going to get very hard to control. People
Of
love
course.
talking about, oh, you can have all these optimizations I'm going to do, I'm going to customize this and all that, and say, you know, I can fit it onto your phone, I can fit it on this device, and I'm like, that's all fine and dandy from running it just to produce something. The question is, what happens when you produce it? How do you sign off that
Yeah.
optimization that you made to get it working is something that I would trust to put it in front of my, you know, my kid, right, who's 5 and 9.
Vijay, so
Nine.
you're all on this call. Welcome to join. On May 20th, Wharton AI Studio is hosting another session on responsible with one of the best in this field. They do all the crisis management, end-to-end guardrails, everything, and one of the best also trainers in this field. Like I am a certified algorithm auditor. They provide these train the trainer things. So it's a huge area. And I couldn't agree more. People are so quiet or clueless about it. And now down the line, you have to deal with a huge mess, financial mess, legal, reputational, everything. So anyways, George, sorry, we
Yeah.
completely.
No, that's fine. No, it's interesting. And
Not all Vijay's fault.
I was lawyer before, saying I'm thinking of those things and how to factor those risks into the investment and process. And it's kind of very challenging to predict those without having any details or any data points that are reliable.
Yeah, but, I mean, unless you actually get to a point where you have a medium where you decrease the size of the model, allow that to be on the edge in some fashion, and then basically have it good enough so that, or maybe specialized so that it's actually producing, you know, I think the issue really is how good are the results compared to the large language models. That's really, I think, part of the equation there.
I agree. I think what gets tricky down here is that because you're deploying it on a rich variety of heterogeneous systems, which is what Evgeny was getting at earlier, that sounds awesome from a pure deployment sort of standpoint. You can cover lots of use cases. But therein lies the challenge of how in the world am I supposed to make sure and I can certify that this model is good to go? Because everybody's making an optimization. And I think that's where it gets really tricky.
And then we talk about SLAs, right? And it gets, you know, into the monetary legal aspect of things in terms of what are you guaranteeing in terms of that. And that also connects to site reliability engineering as well in terms of thinking about operationalizing these things on the edge.
I'll chime in here. I was at a conference for aerospace a few months ago, and this was a hot topic. It was like, you know, in the aerospace and aerospace defense world, it's very deterministic systems, right? And how do you introduce AI, which is kind of inherently not deterministic, into those systems? How do you understand the data sets that the models were trained on, the provenance of the data? You know, obviously the security elements to it, and make it, you know, bound it so that it can work in a deterministic system. So I think these are some of the things that people are trying to figure out as AI it's making its way into, you know, I wouldn't say more serious things, but, you know, you got your washing machine and then you've got your kind of, you know, Rockwell Collins, you know, fighter jet. Those are totally different deployments. So I think as we get into more and more of these things, we'll figure out how to sort of bound them and monitor them and make them safer and safer.
Talking
And it's
about
actually-
that, yeah. No, go ahead.
Yeah, I was going to say this could be also an area for investment, combining these deterministic physical models with probabilistic AI models, because this is kind of a powerful combination to solve the reliability and other type of problems, but still using the power of edge AI. And some companies already using this, like some techniques like RAG, retrieval augmentation. You use the generator to generate things, but you use RAG to retrieve exactly the information you need, like company sensitive information.
Right.
100% accurate. So this is again one potential area combining the deterministic and physical models and probabilistic models. I think that's may improve accuracy and big time.
I've had exactly this situation, but then the problem with RAG and retrieval was that we could not guarantee any protection against prompt injection. So, and that's the point. You change like one small detail into your prompt. You can actually, if you know how to do it, and then it will say all the secrets I've ever had in my life. So it will tell us on the social medias, and that's the thing. And I was wondering if it's possible to this was my question. That's why I wanted to ask the question about mesh networks. But in general, is it possible to envisage something to think of something local that protects, that allows us to do efficient inference, store models, which is kind of combination of the local storages that happens on the local network, which is completely independent from the internet. Is this concept in something that are being now tested or implemented somewhere, if you know of those things?
Actually,
Yeah.
Evgeny's going to chime in. I'll just say if you go to our YouTube channel, which I encourage everyone here
Sure.
to subscribe to, there is a live stream we did with a developer who was developing something similar to this. Like, how do you have a very focused sort of RAG++ model of developing AI answers? And he referred to it as snipe search. But it's on our YouTube channel, and you can see it's like a 1 hour talk, and he does a demo on it and stuff. So I think people are trying to figure out what's interesting in the edge world. These are much more constrained models in terms of the output. Like if I put an LLM or a small language model into a unit that's in my car engine, and I ask my car engine, "What's wrong with you?" I want it to tell me what's wrong with it, and I don't need a haiku or a unicorn picture or whatever. So these models are going to be much more focused in terms of the data that they're trained on, because their function is more focused as well.
Right.
But there are some interesting techniques out there to kind of turn a more focused corpus of data into a much more meaningful answer. But Evgeny, you had a
Yeah, I was going to add that
Here,
another
can you put
technique
that
that
link in
people
the chat? That'd be helpful
Sure.
for the audience.
I'll do
Yeah.
that.
Yeah, I think another technique that people use is federated learning. I think it was pioneered by Microsoft and other techniques. So in this case, these local nodes, they don't share real data; they just share deltas with the centralized model, and that makes it communications more secure in this way. And you can personalize these devices.
Interesting. Yes, anyway, so it may get technical, but I had another idea of actually judging by probabilities. When you see hallucinations, probability spaces, so the variance properties are different when they're compared to when you don't have hallucinations, but it's something different probably. And then we are talking about startups, and Pete, what would be what they should leverage for how they can leverage edge AI to disrupt established markets and gain a competitive edge?
Yeah, I mean, we have a lot of startups in our community. As I mentioned, there's that stack. It's almost like I think of it as like a big deli sandwich, with like all these different slices in it. And there's startups that are providing lots of those different slices, and workload orchestration or ML ops or model optimization. I think a lot of these companies are coming in with a lot of unique innovation that are part of the puzzle. And so that's exciting. The challenge for a lot of startups too is how do you get to market? So, you have this really cool algorithm or this cool piece of the puzzle, but, like Chevron is not buying a piece of the puzzle, they're buying a solution. And so that's where you have to partner up to find a good, route to market with a solution provider or whoever. So I think that's what we encourage startups to do is to partner up and find, it's a team sport, and you need to build a team or get on the right team. And so when we find startups that are on a good team, that you see someone who's innovating and also is partnering with someone who can actually deliver solutions, that's a pretty good combination to find.
Yes, and actually, what I was doing just to say, I reminded me, Pete, before startups started, I mean, in deep tech, when I was meeting with founders, like in 2016, 17, we were talking about those things, and then what I've developed was like before starting the product, I was organizing meetings with potential interested parties like strategic partners or buyers, and in this way they know exactly what they want instead of centering on their own product. And this same logic probably applies to edge. You may want to do what you want to do, but then you need probably to collaborate with these big companies for two reasons. One, if you want to exit and then early exit, and the second is to do right thing, not what that you like, because at the end you have to sell it, right? So and
Right.
we're doing
Well, I mean, Fortune 500 companies they buy solutions from trusted partners, so whether it's Microsoft or AWS or whoever. And so ultimately, Chevron's not going to write a check to some tiny startup to buy a piece of their tech and then integrate it. It's all going to go through some
exactly.
sort of channel.
So they
Yeah. So
want
you have,
to have, yeah.
right.
What about federated learning? How significant is that within the edge AI space, and how important is that to startups and to customers?
Yeah, I think for federated learning specifically, I think it's a niche technique still. It allows to do quite a bit of personalization. The way it works, there is a global model that, let's say, voice recognition model was developed, and this model got pushed to all the devices. And then if you want to personalize this model for each device, what you do, you just collect data from this particular device, like your particular voice or your accent, and then this model shares not your voice with the centralized model, but only the delta from the initial model with your thing, and then the training is happening on these deltas, and that's kind of a way to make it secure, make it personalized. I think what is missing there is a very strong use case for the thing, but again, these techniques are becoming available.
And then where the businesses focus their AI R&D budgets to maximize return on investments over the next 5 years? What is your...
Thank you, George. We have a couple of minutes, and I kind of touched on it earlier, but if I may recap, I think in terms, there are three key words for me in that question: R&D, the AI, the technology piece, the investment piece, and the return piece.
Yes.
So in terms of R&D technology, what I do genuinely think short-term, mid-term is definitely there's this agency piece that we have to take very seriously, and not just from a technology perspective, business model perspective. Then there's all the other stuff about reasoning, composing AIs, etc. All of that, I think all of us on this call are quite aware of it. In terms of investment from an R&D perspective, definitely talent, and even more so from an edge AI perspective. As I mentioned earlier, it's so rare to find the talent who knows the hardware, software, and the AI components. We have to take very good care of it, which also means lots of education, to Vijay's point earlier, upskilling, reskilling what we have. In terms of the returns on investment, I don't think there is any magic formula, at least from what I can hear around me or observe around me. But team, the founders, people who actually do stuff, and partnership alliances, the ecosystem. And that's why, to me, it's extra meaningful to bring such two amazing ecosystems together on this call, Edge AI Foundation and Wharton. That's exactly what we need to do to succeed on our investments and maximize returns. We are at time, George. I don't know if you're able to watch, but
I see.
I want to thank you for doing such a fantastic work with Wharton AI Studio, UK Club, and huge thanks to my friends at the Edge AI Foundation, honestly.
Yes, thank you so much. Time is up. I hope if there is like one emergent question or anything, or you can always contact directly our guests. And so thank you guys for talking to us. Thank you, Didier. Thank you, Pete. Thank you, Evgeny. Thank you, Vijay. And hopefully we'll do interesting things in the future. And when we will start investing together, you will be our best partner, hopefully.
Sounds good. I appreciate the time.
Thank you.
Thank you.
Thank you so much.
Thanks, everyone. Bye.
Bye-bye.
See ya. Thanks. Thanks, George.
My pleasure. Thank you.